Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
From the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
Welcome to this stream, everybody. Wow. Here we are. So we are slowly transitioning over to more science-based streams. I still have the pieces to get out about MH370X. I just don't feel like working on them tonight. So instead tonight, we are working on, we're going to be looking at monopoles and magnets tonight. Tonight's stream will probably only be for about an hour. Because I want to get back to getting the other Hard Truths podcast uploaded. So, quick shout out to the Hard Truths podcast. If you've probably seen now that I've gone ahead and I've re-uploaded the first 4 Hard Truths podcasts on video on YouTube as well as on audio version as well. The reason why it's taken so long is I've been actually listening to them and trying to edit them if there's anything in there I need to get removed or anything like that. And I've also been getting ready to clip some of them. So, if you want to check out the audio versions of the Hard Truths podcast, it can be found anywhere where podcasts can be found at this point. Apple, Spotify, whatever you want. Also, you can check it out on YouTube. On YouTube, I've made a podcast playlist now as well, where I'll be adding the additional ones. So the next ones will be Roy D. Herbert. I'm going to post on there. I'm going to try to get the Roy D. Herbert and the Chad from Investigate Earth ones on there tonight. And then I'll get Timothy Abarino uploaded tomorrow. And then I'll also go ahead and premiere Mark Sokol, who we've been waiting on for a while. All really good discussions, all really good conversations. And then I'm also going to try to clean up some of the thumbnails and the search engine optimization, the search terms, stuff like that as well, so they're easier to find for people. So thank you guys for listening to that and helping out with that. There's definitely some really awesome clips, especially when it comes to the Salvatore Pais and Dave Rossi stuff. As a spoiler, one of the clips that I found, Salvatore Pais, I forget what I asked him about. I think for some reason, all of a sudden he started talking about scalar physics. And he actually mentions that he doesn't understand why they zero out the one Maxwell equation. And somebody was arguing with me in the comments from the stream last night as well. And that's what we found from Tom Montauk's Monopoles, or his Scalar Physics YouTube, was that the math, they basically just don't understand how to explain scalar physics, so they just zero it out in the Maxwell equations, which isn't the correct thing to do, and this is why scalar physics has been kept secret. People think it's not possible because they can't measure it, so they can't understand it, so they just zero it out. But if you don't zero it out, and now scalar physics comes back into play, Salvatore Pais says this in my interview with him and Dave Rossi, the one I just uploaded. If you go near the end, he mentions it, and then he also mentions magnetic monopoles being possible, and to look at the Dirac equations as well. Pretty huge clip, if you ask me. At some point in the interview as well, he mentions that he's actually looked at some of this technology from the engineering perspective, like hands-on. He even talks about the team of like 15 people that he's worked with. So people wonder, like, this is what we're struggling with, chat. This is what we're struggling with, is that there's people who are literally working on it for the government, for the Navy, for the military, for the DoD, We've been interviewing them. And then there's people out there that are just academics that think it's all fake because they've been taught incorrectly. And all it takes is to zero out one number, and next thing you know, they don't worry about gravity. Now gravity can't be manipulated anymore. And now you have people like Eric Weinstein who think all this stuff can't be real because he thinks, oh, they would never lie to me in the textbooks, right? I saw his post today about like this guy is. I don't think he's disinformation. I think he's just, and it's hard to call him CNN brain because I'm pretty sure he's right wing, but even some of the people on that side of it, like even though they're not CNN brain, they just don't realize how easy they're lied to, you know? It's sad. Also stuff like room temperature superconductivity as well, which we'll be looking at as well. There's a patent for graphitic room temperature superconductor that's out there. We'll be posting that tomorrow morning. So, without further ado, also, yes, you saw the size of that martini? It's not a joke tonight, chat. It's not a joke. So, yes, hello, Dorian, buddy. Thanks for being here. MN, PJ, Mike, Sandy, Beninator, Langley, Billy, Amanda, Pamela, Sandy, PJ, Antonio, Alex. Well, a lot of people in here. Evan. Appreciate you guys jumping in early. Skinny Bob, I see you too. Roy Marshall, Krakadana, Anthony. I think I got everybody there. If I missed you, I apologize. Thank you for jumping on early. Okay, also just quick housekeeping. I will not be streaming on Friday or Saturday this week, so I will most likely be streaming every other day this week, Monday, Tuesday, Wednesday, and Thursday. I won't be streaming on Friday or Saturday, and then I'll be back on Sunday. So, going out of town, going to meet up with some people. Should be a good time. Okay, should we dig into it? Let's get started. Man, what a lot of connections, right? Like, I'm sitting there and I post out earlier today the paper. Okay, well, guess we're just revealing DMs. Fine. Here, I'll just restart my thing. I was posting out this patent. So we found this patent last night, chat. Pretty big. Here we go. We're back. Also, looks like there's some YouTube videos that were or some UFO videos that were found. But guys, I don't know. I'm just not excited in UFO videos anymore unless it's like showing something crazy. You know, you kind of get spoiled when you get the MH370 videos. And then you got to look at just some lights moving around at normal speed. It's like, nah, it ain't doing me any good. So we posted the patent earlier today of this Boyd Bushman magnetic beam generator or amplifying magnetic beam, and people were jumping all over it. People are talking about, oh, I'm gonna make one of those, or I've made it before. And it was important because, and if you want to check, I just posted the interview with him as well. A lot of people were asking me about it. So I posted the Boyd Bushman interview as well here, where he's like literally talking about them having alien bodies and anti-gravity and all this stuff. And I don't know. I don't really know if I believe in all the alien stuff, honestly, chat, but he definitely doesn't seem like a guy who's lying intentionally. I mean, he's like on his deathbed here. He died like right after this, I think. So he seems like a genuine guy to me. But then again, I don't know. I've been scammed before. Who knows? But that's why it's kind of important that he came out this patent. He actually was 100% an engineer at Lockheed Martin. No question about it, right? And this patent is one of the patents where it's like, this is up there in my mind with coherent matter beam generator or coherent matter wave beam. In potentially one of these patents that's like, this one's more fundamental framework for what we saw in the MH370 videos, because you can conceptually understand it, right? Where you've got a triangle that's around the plane, you've got our orbs, they're potentially magnetic monopoles that we're seeing, and then they're converging on the plane, amplifying the energy, and this is what's causing the singularity, where the plane is then, imagine it like surfing on a gravity wave towards the last orb, which would be in the direction of the beam here. And you don't probably need this front magnet because you've got some other counter. The fourth orb acts like this magnet does. It's somehow entangled them to create this type of effect, right? Now I'm speculating here. This is just theoretical physicist, not a practical and engineering one. But pretty cool, right? Now, in the replies, we started getting people like Bob Grenier was showing up in the replies. We had Matthew Rife in the replies. Is it his dad or his grandfather that was the Rife machine? I don't remember which one. But pretty damn cool. And then all of a sudden, Bob Grenier posts this video saying, I discussed this patent. It was like years ago. So I took a look at it. Here it is. Now, we're not going to go through the whole thing, but there's a couple of really cool parts. So he takes the magnets and he aligns them together in different patterns. And here's one of them. Let me fix my sound.
I come down on top, you can see the sort of field configuration that you get from a standard two magnets.
So here you can see the configuration when you have the magnets together. Look at that, chat. Doesn't
now
that look really familiar? It looks like a toroid from a side.
In here, which I've got
plasma with the dome shape, the mushroom,
look at this,
as they call it. Now look at this one.
Indeed. So there's kind of like a beam coming out to the side, and then you obviously have a south to one side and a south to the other side. So it's a very, very different configuration. And in fact, if you actually take
I have it on fast speed
now, and we put it, say, on there, we get an even more sort of focused beam. And if you look at this, look.
Look at that.
We have
Look,
this kind of
chat,
beam coming out here.
look at this, chat. There's Thor's hammer right there. Right? This is what I think Bob Grenier talks about, the eyes. Like, look at this shape that's being formed right here. This immediately I went, whoa. And granted, what we're looking at in the video is much more complicated,
was
but
the kind of process that Boyd Bushman went through to come up with his patent. And here is a still from a video, which I'll give the link to, but it's a simple model of the configuration in Boyd Bushman's patent. And essentially, you have these large, strong...
Yeah, I don't know if people should smoke less or smoke more for this conversation. So I guess I'll just leave that up to you, to my
neodymium magnets.
My herbal remedy followers and viewers.
And I don't know if you know, but if this configuration, so you could do this with, if you have very strong magnets, have been material in between them, this causes a reduction in the stress in the physical vacuum, and radioactive materials would accelerate their decay under arrangement, and you have a radioactive material.
Look at this arrangement we've got going on right here. So this looks even more complicated right here.
In between them, this causes a reduction in the stress in the physical vacuum, and radioactive materials would accelerate their decay. And this is interesting because gravity and the physical vacuum have been talked about as being related in terms of neutrinos for a very long period of time. And this brings me back to what is being said by Boyd Bushman in this video, which intrigued me so much. At the end of the video, having connected the Hutchison
I mean, here's the video right here.
To next energy levels that are not wind, solar, or atomic, or anything like that, and the fact that this magnetism is related to gravity, he then says this.
Well, there is another universe called the neutrino universe, of course. We know that it's there, and now we were seeing if one of the additional forces matches it. Not only that, we know that everything that we see is...
Whoa, chat. Neutrino universe? Guys, are you thinking what I'm thinking, neutrino universe? Guys, when I say neutrino universe, what comes to your mind first and foremost? Put it in the chat. I want to see if anybody is reading my mind here. What do you guys think about when we hear the word neutrino universe regarding the stuff that's been in the zeitgeist out there the last 6 months or so?
Is about 5%. And then there's dark matter that we don't see. And then beyond that is about 70% of dark energy. And that's what we're talking about. The energies that we don't now have catalogued, and we don't have name for, and we haven't done critical tests on, and that we're just barely beginning to start operating with.
Thing is, I like Roy D. Herbert's explanation for dark energy and dark matter better. Antarctica, there it is. I was waiting for it. Anthony Williams, Antarctica, the neutrino detectors in the Antarctica chat, where that one guy was talking about shooting that it's not just a detector, but it could be a weapon. Boy, that's weird, chat. That's weird, man. I might actually have to look into Antarctica. I don't know. There's too much stuff coming together, right? It's just it's too much stuff connecting. And I mean, I understand why people can't believe it. I mean, holy crap, guys. Holy crap. It's just... Anyone who really doesn't believe, though, should just watch the interview with Dave Rossi and Salvatore Pais. That interview I just did with them that I re-uploaded is them just speaking entirely off the cuff. Like Salvatore Pais was probably saying way too much, right? And Dave Rossi, like, I don't know. I worry about both these guys, man. They're talking too much, man, and information's getting out there. And if I can figure it out from what they're saying, especially now that I've been looking into the physics of it, and I've got no filters. I don't care. I'm just going to say everything. Everything that I think is going on, everything that I think that I'm hearing, I'm just going to put it out there for you guys. It does make me worry. I hope they're protected, is what I would say. I hope they're protected. And I think that it's crazy because I would want everybody else who's out there to go through the same kind of experience that I've gone through regarding all this. Because unless you're in the driver's seat, it's hard to really understand it. Now, I think some of the people that have been here following along for months and months and months, potentially from the beginning, they probably have the best perception of all of this, right? Because, like, you know, you've seen all the people, the way it's all gone down, the people that have come and reached out to us and we've talked to and what have you. But even you guys are only seeing like one half of it. You guys only see the stuff that I present, not just the stuff that I know and the people that I talk to behind the scenes. And I'm not saying I have like secret knowledge or anything like that, but people say so much up in front, but then you also have all these other people that you're connecting with and hearing all this other stuff too, and you're just going, whoa, okay. Yeah, like, what did we just get ourselves into, right? And it's like, that's why I say stuff like maybe I'm being used to a degree to help get the information out. I'm very certain it's real. It's just a matter of like, am I being used towards disclosure? Or are people trying to stop us from doing it? I don't know, man. Don't know. Hey, Yoga. Hey, Memory Hold. Hey, Z Jalapeno. Hey, Tony. What's up? Yeah, Dave. Hey, Tony. Dave is super busy with stuff, but he and I talk a lot. But he's really busy with stuff in general, and yeah, I don't know. I hope more to come with him as well.
Effectively, what it's saying here is this neutrino universe is part of the overall universe, but it's not something we normally consider. And we're only normally aware of, let's say, 5% of the universe, and about 75% or 74% is this other type of energy and matter in the universe. And in page 67 of
okay, so he's talking about we can't see a lot of what's going on in the universe, is where Roy D. Herbert would come in, and Roy D. Herbert would say, my RAM is crying out for help. Chrysler, you got to help me out. I'm too boomer. I don't know what all these words mean. Do I have some RAM somewhere? I'm just kidding. I was going to say, crap. Roy D. Herbert would say that dark matter is just complexity increasing, right? I actually replied to Brian Keating's, one of Brian Keating's posts, where he was talking about a very similar idea of entropy increasing. And I think that quantum gravity and complexity can explain dark matter and potentially dark energy as well. Although dark energy, I think, would make more sense regarding the idea that, like, maybe the universe is just infinite. Maybe there wasn't a Big Bang. I can't read launch right now. You guys, look how many windows I have open. Look how many windows. Oh, okay. Yeah, I don't want to show my emails. Okay, here we go. Anyway, we're going to get to the good part here.
Alexander Parkhomov. You can see this chart where he's talking about the different matter and energy components of the universe, and this is essentially what Boyd Bushman is talking about here. And he's saying that of the dark matter, there is 0.1 to 2%, which is the neutrinos in the universe. And so he's kind of potentially talking about accessing this material. So there we have it. We have Boyd Bushman connecting anti-gravity to Hutchison, to the neutrino universe, to magnetism, and being able to focus magnetism, and accessing potentially this. And a wall plug, and I'm going to screw these two together such that the same pole is pushed together.
Okay, so
I'm using a pair of Gerber pliers.
Okay, so he's squeezing the poles together that are the same, so they have a repulsive effect, right? That's what he's doing here.
Here's the finished item, which is something that I can easily hold in my hands.
So the outsides are the same magnetic field, and the insides are the same. So it should be repelling one another.
And we'll see what it does. Okay.
Now this is the cool part. Does this remind you of anybody else's experiment?
If you turn it around 90 degrees, you can barely see anything. Move it over here. Move it over here.
Chat, if anyone else understands this better than me, please let me know. No, things generally get more and more complex, Tony, like a line growing.
They're both the same poles facing towards each other. together. Okay. Green above, red below.
I don't know which one's positive or negative, but I'm not sure it matters.
I'll turn it all the way around. What do we see? Green above, red below. Green above, red below. Green above, red below. Green above, red below.
Whoa. It's always green above no matter which way you flip it. Huh. That's weird, right? So it's theoretically like two south poles jammed together and then two north poles on the outsides, right? So if I were to draw what he just did, right? And I don't know which one's which. Also, for anyone who's trying to recreate the Boyd-Bushman, there was a bunch of comments as well. So there's another video that someone posted, and in the comments, there's like some pretty interesting comments where somebody, like, every once in a while you read something, you're like, huh, seems like these people know more than they're leading on. So with your magnets that he's got jammed together, right? He's got two magnets jammed together. You've got, let's say, we'll put red sign here. You've got your north. Your norths are on the inside, right? And then your souths are on the outside. But for some reason, when we look at it, we still see green is always on the top, which would make us think that the magnet somehow, like, I don't know, reorienting itself back in a position where it's like north, south, and then north. I don't know. I'm not sure how to think about it. Or maybe it's just a matter of the pixels. I don't know. Maybe it's something else this basic.
I'll have just a straight magnet here. I'll put that on there. So you get this kind of field.
Now this is weird. Look at that field.
Not good for your CRT screen.
Huh.
Okay. Okay, and this one, very different. So, very, very different field structure.
Yeah, very different field structure on those, right? So one has them connected together the way they naturally want to stick together, and the other one has them pressed together opposite.
South, north, so it's kind of doubling the strength, and you'll see it's a very different effect.
South, north, yeah. Wow. So this one is one where you've got
in this test, I
like doubling the strength there on that,
together, so whichever it was, north or south,
as opposed to trying to negate one another.
North together, it's now south together.
Okay, so north, south. So yeah, that's the one we were looking at in the beginning, right? Wow, so it's very tiny.
Okay, so again, it's whatever's going on is highly suppressed. Look at it here. Basically no effect. The two magnets, very, very different effect than when you have them together.
Huh.
And that's it, really.
Very interesting. Now green's on the bottom, though.
Done before by other researchers. Maybe there is someone that's done it before, of course. Certainly in that orientation, where it's most extreme when you put the magnets together, there's almost nothing you can see. There you go.
There's nothing there. Look at that. You see nothing.
There might be slightly different magnetic strength around it. So if I rotate it around in a little bit of red there, if I rotate it there, it's basically nothing observed. You can see something there. If I rotate it around, yeah, some planes there's almost nothing.
What we're looking at here is like the magnetic field, right? That's the idea here. Is a visualization of the magnetic field. Yeah, look at that.
In this image, where we have the north-south, you can see on the right side of the paired magnets, you have red on the top and green on the bottom, and this shows the spin in one way. And on the left side of the paired magnets, you have the red on the bottom and the green on the top. That's the spin in the other way. So you've got the two vortex there. If you actually look at the magnets which are arranged in the north-south, south-north configuration, we don't see any of this, and it's only until you rotate it so it goes horizontally you see a little bit of color above and below.
Yeah, so you said north, south, south, north, right? So this is actually the opposite of what I drew here, right? So, so really what it is this is north down here. The middle is south, south, right? And then the north up here. So these are opposing magnets because they have the same polarity, so they're going to try to repel. When you look at it like this, then you see basically no magnetic field when you hold it up against the screen. When you switch it up, then you see this huge magnetic field. So I think it was like north, south, and then north, and then south, right? then you see that huge field because these are sticking together, and so this is then creating one giant magnet, right? As opposed to a weird effect where it's kind of canceling out. Now, why is this relevant, chat? Why is this relevant? Because the idea that we are looking for a magnetic monopole, we're trying to come up with a configuration where you can actually see an outward monopole or an inward. If you look at the thumbnail, I changed the thumbnail today. We're trying to come up with a configuration where you can create that magnetic monopole. Yes, I did. I think I did add subtitles. I think it has to do with adding the language, but Salt, go ahead and let me know afterwards if the subtitles are showing up for you, please.
But it doesn't seem to matter which way up it is, and this may actually be bleed through from the hole through the magnet. I don't know, because it may be that Boyd Bushman had a specially configured one where it had a screw thread on the inside, and so there was no sort of hole going through. Certainly we can see from the earlier test that there's a slight imperfection, and this may cause a bleed out from the side. Anyway, I'd like you to say what you think about what's going on here and why we don't see any influence of any real.
How does he add this thing at the end? I need to add these things at the end.
Ray gun and.
I'm a noob on all this stuff, chat.
Compared to when you have them in the north-south configuration. So thank you very much for your time, and I'll see you in the next video.
Chat, did I see Bob Green? You're talking to Ross Coulthart there at the end? That'd be interesting. Ken Wheeler's video about his anti-gravity device. He has 7 different forces. Ken Wheeler keeps popping back up, huh? Yeah, Halbach array. I think we are going to look at that, actually. A lot of people were mentioning that. Halbach array. Good night, Salt. Yeah, let me know tomorrow. Salt, tomorrow, post a comment on the stream. Let me know if the subtitles showed up. I really don't know how they work. Okay, so here's my take on it with the north-south configuration, which is identical to a north-south configuration. You have spin going in one direction only. When you have north-south, south-north, there will be spin in one direction and the opposite direction, so that the spins cancel. You see no effect. Interesting. Just click on Fractal Woman. Oh, I was like, wait a minute. I was like, that's a risky click, chat. Very risky click, chat. How Boyd Bushman came up with his test. Yeah, we looked at Ken Wheeler's CRT stuff before, I think, as well.
I had purposely placed opposing magnets that didn't like each other, like two norths together, and I had already done an iron filing test that showed that it was showering out an entire magnetic plane, and I wanted to see how that magnetic plane interfaced with gravity.
He showed me a film of extraordinary experiments that had been done in Canada 10 years ago. A scientist there appeared to have found a way of getting objects to defy gravity.
This is the Hutchinson effect.
Waves of them. Most people had written it off as a conjuring trick, but Bushman took it seriously and was trying to develop his own techniques.
I'm refining and heading towards something that all you have to do is charge, and it is lifting.
I think he's talking about Hutchinson right here.
Wait, when we complete the technology, it should fly.
I was astounded that someone of Bushman's standing should seriously discuss the notion of anti-gravity with me. His experimental work.
Yeah, he was pretty open about his information, huh? Now, where was the other video? Here it is. Here's the other video. Okay. Free energy. Now, this one's not that great of a video, but
welcome back.
Somehow it's got 42,000 views. Sure. But the replies, chat, the replies. And there's the Halbach array right there. We're going to take a look at that. We're going to look at the Halbach array after this. Which one is it? This guy down here. Some random person with numbers in their names, chat. First of all, for my noobs out there, people with numbers in their names, very suspect. Memory hole at 370, you get a pass. Look, 66 replies in here. I read them all earlier today. It's efficiency based on distance of the poles from one another. Too far in the fields fold. Get them nice and close, though, and you can compress the centrifugal forces causing displacement. And then he also mentions same thing with the North Pole. Oh, wait, he said more here as well. He said, major heads up, put the North Poles towards the center, not the South. Huh. But this guy defies the rules about being a noob, though. Like, he definitely knows some stuff. We're going to read through some of these as well. And he mentions using brass because it doesn't interfere with the magnetic field. And then he starts talking about as well, similar 10-ton metal sphere versus 10-ton metal boat. Only one will float. Imagine the sky is water, treated the same, yet let it be magnetic water. So you want to float on the magnetic waves, right? Let's see. Somebody asked him, what do you mean? See Fleming's right-hand rule. You need a coil with a very high frequency and a magnetic field. The stronger the magnetic, the smaller the field. Caduceus staff. See Hermes. It would be similar as a coil called the trident. And then he shows some math out here as well. 1 over pi to the, or phi to the -3. All space agencies know this. That's why they all have the same two-sided triangle in the logo. It's the same ratio drawn into geometry. What triangle, chat? Hey, Alien Girl, what's up? Hey, Alien Girl, did you ever end up posting your interview with Jake? Curious. Let's see here. So let's see what else he says. The fib sequence is not the source of life. You know, like when you have to turn the radio on, there's no band or music inside the radio. It's transmitting a source. Life is the same. For the lack of a better phrase, humans are radios. We receive life. We aren't life or capable of experiencing it. Damn, this dude is deep, chat. When people start dropping these bombs on you, that's when you go, wait a minute. This dude sounds like either he's crazy or he knows something. And sometimes the line is pretty blurred. Sir Walter Russell's periodic table of help. It's very advanced for the time. He presents it to Nikola Tesla, and Mr. T says, hide it for 1,000 years if you want to stay in the industry. Whoa. Wirona, I'm not sure how you do both at the same time. There's not much going on in the Discord right now, though. I wouldn't worry about it. Let's see. And then this guy spams him like 20 replies here. What they say falls in line with Nikola Tesla's work. Nikola Tesla, the busboy at the New York apartment was Otis T. Carr. See his patent for the amusement device. Like, this dude just, like, he knows. His works use the same principles, easiest understood via Thomas Townsend Brown's works. Hence the top disc and coil. Huh. See Larmor frequency. All shielding is water. Chat, that's one I haven't heard. Larmor frequency. There we go. Okay, I think that's about all the comments. Let's see. Oh, see MRI machine for correct Larmor application. Oh, and then he drops Apophis. He drops Apophis, chat. This is weird, man. You guys know what Apophis is? Apophis is the asteroid that's in 2029. It's going to come closer to us than our geostationary satellites are. It's going to be the closest asteroid to come to us within, I don't know, millions of years or something like that, or in terms of all of human history. TH600 Mike. That's awesome, man. I don't think you're going to get that 50K, though. To get the power levels required to lift an object in zero gravity, it's going to be quite difficult. It's possible, but quite difficult. You need a lot of equipment. A lot more than $50,000 worth is the problem. But yeah, Apophis is going to be, and here's the thing, chat. If Apophis is even like 1 or 2% off, I recommend you guys Google it, or you can check out my Twitter post about it I did a couple weeks ago. In fact, let's just go look at it right now. It's fun. It's cute. Side quest. Apophis. Just watch how freaking close this thing is going to come to us. Where's the... Yeah, here it is. Can I make this bigger? Watch how close this comes. The pink is Apophis. There it is. You see it just overlap with us right here where my mouse is? It just overlaps with us right here. Like it's coming. Like right here in this dot. So you can see it's 2028 here. When it loops back around, like it's on top of us. Like right there, boom. That is a very, very, very close shave. If we are even slightly off with our understanding of gravity, then that thing's gonna hit us. That's that's cool. That's much better. Look at how close this is. Yeah, I'm aware it's high voltage, low amp, low current, high amp, high voltage. Hey, if you can do it, man, you can do it. I can't wait to see you on there. I would love for it to be true, my man. Apophis is, I believe, 1,000 feet long. It's not a world ender. I'll just let you guys know it's not a world ender. Yeah, 450 meters, so yeah, 1,100 feet, something like that. 1,100 feet is big, but it's not that huge. I mean, it's not going to destroy the planet. Also, the angle, like the way it's coming at us, it's not like shooting at us, right? It's with us, right? So even if it were to hit us here, it's not coming at a speed high enough that it's going to wipe out all of the planet. But it could destroy a whole metro area. Like, what if Atlanta was just wiped off the map, right? It's pretty messed up. The good news is we'd have enough, would there be enough time for people to evacuate? They would be able to probably like a week or two before, right? I'm just guessing. They would be able to pinpoint exactly where it's going to hit. Pretty scary, though. Yeah, I don't really understand. I don't trust our understanding of gravity, man. I really don't. Especially when it comes to NASA. So, yeah. Yeah. Do we really need Atlanta though? Touche. Maybe we can. I'm not going to be dark. I was going to say another city, but you know, let's not do that. Oh, Kreishley is treating me like a boomer here. Kreishley is definitely TikToker. Control middle mouse. Yeah, I'm aware. I know I can do this. I was hoping I wouldn't have to. I got too much boomer in me, man. It was funny when Lou Reviews was asking me if I had made the videos. He's like, I think I was muted, so I had edited the part out. But the first thing he asked me is whether or not I'm registered on. And I think you might have the secret VFX skills. I'm going, you've probably not watched my streams if you think I've got the secret VFX skills. Okay, so anyway, he mentions Apophis down here, which is pretty damn weird, if you ask me. Pretty damn weird. Because I think that if you think about the people making bunkers, that could be one reason why people are making bunkers. There could be a lot of reasons, but that's one of them. Okay, so we've got that. Let's look at some other stuff, chat. I don't want to go too long tonight. Let's look at the Larmor. Oh, Larmor? Yeah, Larmor frequency. Okay. Pulse and microwaves is applied. Guys, I think we need grok. And what did he say about the Larmor frequency? Oh, MRI machines. I don't really like Grok. I kind of like ChatGPT better. Let me see what ChatGPT's got going on. Let's compare the two. What is the Larmor frequency? I feel like there's no science streams that are as hardcore as mine is. The Larmor frequency, known as the cyclotron frequency or the gyro frequency, is the angular frequency at which charged particles precess or rotate in a magnetic field. It is named after Joseph Larmor, who first derived the formula using this frequency. The Larmor frequency is given the equation. I'm not good with all my Greek letters, where the W is the Larmor frequency, Q is the charge of the particle, B is the magnetic field strength. So charge times magnetic field strength divided by 2 times the mass. Okay. The Larmor frequency plays a crucial role in various fields, such as nuclear magnetic resonance, NMR, and magnetic resonance imaging, MRI, and electron spin resonance, ESR, spectrometry. God, it's always a hard word to say. Spectroscopes. Yeah, I give up. In these applications, the Larmor frequency determines the resonance condition for the interaction between the magnetic moment of the particles, such as the atomic nuclei or electrons, and the external magnetic field. Actually, ChatGPT says the exact same thing. It actually says the exact same thing. Yeah, wow, they're identical. They basically say the identical thing. Although ChatGPT is a little bit more, that's ugly. Pretty similar here. Okay. Electron in a uniform magnetic field. Huh. Okay. Let's look at this video. NASA, never a straight answer. Correct. Okay, so this is just going to have ocean waves in the background? No external magnetic field versus applied magnetic field. This is like made on like GeoCities. That was the right-hand rule, chat, if you missed it. Right-hand rule again. Nucleus in the absence of magnetic field. Okay. Nucleus spins around its own axis of rotation. Okay. Now, if you apply externally applied magnetic field, I don't get it. Seems the same. Is it changing the spin? Is that what we're getting at here? The magnetic field exerts a torque on the magnetic moment of the nucleus. Dude, is this like, am I at the zoo right now with these sound effects? I'm just turning the sound effects off. The rate of change of the okay. That was going a little too fast. I think I get the idea though, right? The spin of the magnetic field is altering the spin of the atom or something like that. What does the torque do? Good question. Here we discuss static magnetic. I mean, they go way too fast. This torque tends to align with the magnetic field. Yeah, okay. So yeah, it's gonna change, right? Okay, aligns the magnetic field. Got it. Now what? Precess around the magnetic field. Okay. Yeah, it's too fast. Is it? Do I have it on speedy mode? Maybe we just need to turn it on like slow mode. Spinning orbiting magnetic moment tends to precess around the applied external magnetic field instead of aligning. That's the Larmor precession. Okay, Larmor precession. Nucleus tends to precess around the magnetic field with a frequency, the Larmor frequency. Okay. Geomagnetic ratio, whatever. Is that gamma? I don't even know. Magnetic dipole. Come on. The hell. Spin angular momentum. Magnetic dipole moment divided by spin angular momentum. It's mu divided by I. Megahertz divided by Tesla. Applied magnetic field. Okay. Too complicated for me right now. Clockwise. Mu and I are parallel. Clockwise rotation. That seems wrong. Anti-clockwise. Anti-parallel. Okay. Now, why the Larmor precession? Yeah, it feels like they like doubled the speed on this, right? It's like ridiculous. Dorian wants to touch tips, guys. Magnetic momentum, applied external fields vector B. Okay, don't know what that means. What happens? Torque compels vectors to align. Torque causes perpendicular changes to the vector, thereby resulting in a Larmor precession. Larmor precession visualized. Larmor precession visualized. Man, these are too long. Let's try this one. This one doesn't even have sound.
In this diagram, you can see that this is a spinning top and it rotates about its axis. This is the direction of the rotation of spinning top. This is axis of rotation. Moreover, at the same time, this axis precesses about the vertical.
Oh, okay, I see it.
This is the path.
So you're saying that this is spinning this way, but this is it's spinning around this line right here in kind of a cone shape. Okay, I get it.
Path of precession.
I'm starting to understand it.
Which is the direction of the gravitational field.
That's the direction of the gravitational field, straight down. Okay, yeah, so it's spinning around like a top here. It's also spinning in this way, but it's spinning there too.
A proton spins as well as its axis of rotation.
So think of it like the planet, right? Like the planet Earth, how the planet Earth is on an axis like this. Same idea here. So the axis that's spinning around here, it's spinning there, but it's also spinning this way. So if this is our Earth, right? This is the spin of the Earth. This is the equator here. And then it's also spinning around like a top.
This is about the direction of the external magnetic field. Therefore, it must be clear that a proton does not align itself directly along the external field, but its magnetic axis, this one, it rotates about the direction of the external magnetic field.
Slightly more complicated than Lorentz.
This rotation or gyration action is known as precession.
Okay, so because this is the gyrational movement, right? Because you think of a gyroscope where it's moving on more than one axis at a time. Same thing here. So it's spinning here, right? But this is also spinning here. So that's what they're saying. This is spinning here, the axis of spin, and then the second spin right here where it's kind of like looping around like this. I don't know, whatever. Interesting. Okay. Let's look at the Halbach array. Let's see, 3 minutes. 3 minutes looks like a good one. Well, both these look good. We might look at both of these. Why are magnets so sweet,
This
chat?
block magnet, sitting inside the magnetic field inside a Halbach array, twists to align itself with a magnetic field.
Wait a minute. What? I'm looking at the arrows here, so they're pointing north, presumably, right?
This magnetic field in there, about 12 gauss strong, twists or torques the magnet.
Whoa.
Pop up and align it. It's the same kind of magnetic force that twists a compass needle to a line pointing north on the surface of the Earth. Now this force is not quite enough to lift it.
Can't lift
when
it
we
up.
orient this rectangular magnet long ways. The gravity force has a little extra torque and makes it fall down.
Wow. Yeah, so this is south over here on the right, and then this is north up here. And you can see the arrows.
This thinner magnet, it's a 2-inch by 1-inch by 1/16 inch thick magnet. It wobbles back and forth for a long time. We found it kind of mesmerizing to watch.
So you can imagine perpetual
Now,
motion,
the strength
right?
of a magnet, its magnetic dipole moment, is really a measure of how much torque a magnet feels in a given magnetic field. So here we're putting a weight, a dime in this case, to help push down the magnet. The torque of the dime pushing down holds it down. When you reduce the torque, at some point, the magnetic field wins and flips it
Yeah,
out.
it's going to flip it over.
And all that's
Damn, that's cool, chat. That's pretty sweet. Yeah, I kind of gave up my bismuth experiment. I got too lazy with it, but I still have the stuff. I made one plate.
dependent on the strength of the ambient
Bismuth is
magnetic
pretty
field.
damn cool.
Here we put a 1-inch rubber-coated block magnet inside a much stronger array.
Okay, so what's the difference about this array, chat? First thing is that the magnets are closer together. They're closer to the center point, and there's more of them, way more of them. Let's look at the orientation. So this, where the direction it's facing is north, right? They've drawn that out there, so it's easier to see. I have one of these magnets right here. Neodymium magnet, whatever you call it. I got one of these bad boys. This thing's heavy, man. I'll let you know, this thing is heavy. This thing has got some weight to it, right? And this is a very, very powerful magnet. Very powerful magnet. I try to keep this away from all my electronics because it's just extremely powerful. Do you want me to? I would have it pick something up. Let me see. I'm kind of scared. Wow. Holy shit. Okay, so this is Lulu's brush right here that we've got, chat. Watch and observe. I'm actually scared, chat. I'm actually scared. It's actually not even easy to peel it off. Let me see if I can make it easier for you guys to see. Right. Pretty cool, huh? Oh. It's pretty powerful. This magnet does not mess around. You definitely don't want to be around any knives with this thing. So the arrows, though, how do we look at these arrows? Kind of interesting how the arrows are aligned. Like, that's not how I would imagine them. I would imagine like a sunflower going out, but actually you can see they change the angle as they approach towards the southern side, and then they rotate as well while they're moving in that direction, and it's equal on both sides, right? They're both faced directionally the same. And then on this side they're facing north, and that side they're facing north. So what I would imagine here by looking at this is it's gonna flip up, and it's gonna push all these coins right off of it. The moment he lifts his finger off this, these coins are gonna go flying over here to the left and the right, and then the thing's gonna flip up. It's gonna flip upright. That's what I imagine, right? So if this right here is the thing he's pressed down on, you've got your coins holding it up. God, I don't really have good examples here. Like this ketchup packet is a coin, right? It's going to immediately flip up here, and then the packet's going to go flying off. The quarters are going to go flying off.
Gave us about 73 Gauss in the middle. And it takes a lot of
It's
quarters
gonna
to
go
hold
to
it down.
yeah, it's gonna go towards the direction of the north, which is this way, right? Yeah. See, wow.
That was about $3 worth of quarters.
Flipped up just like a domino.
There's a lot of force holding this magnet.
So we guessed correctly on that. We're starting to understand magnets, chat. Look at that. Look at it lifting up already. You can see it lifting up a little bit right here. Now it's off the ground. Boom. How many quarters is that? Like 9 quarters?
Now,
wow.
If we take the same exact magnet and put it in a weaker magnetic field, it doesn't take nearly as much force to hold it down.
Yeah, so you can see this one's weaker, right? Because A, there's less magnets, and B, the magnets are much further apart. And the numbers on here is where they're measuring the Gauss, right? So they've measured the Gauss.
On it is a lot weaker. Here, a single dime can hold it down. But it really doesn't want to go.
In my mind, we could build an array with this. Like, why can't we build an array that could create a perpetual motion machine? Like, just imagine the thing in the middle. If instead of it flipping up, you want it to spin around, right? Couldn't we realign these magnets in such a way and make them close enough where they hit some kind of resonance, where then the thing just spins perpetually? That'd be pretty cool. That'd be pretty damn cool.
The
like a combination of the two.
Depends on the magnet itself, but also on the strength of the magnetic field it's sitting in.
That was cool. What was the second one? Like, this is the same. So now imagine what Bob Grenier showed, right? Where he stuck to like the south-north, north-south, or vice versa. And then you remember when the magnetic field was not visible anymore, right? This is a slightly different configuration. The north here is trying to touch the south, so you have this strong configuration. And then this over here, the south is touching the north, so you have this weak configuration. Okay, so now it makes sense now. It makes sense now. Now I understand it. So the closer, so what's happening then when we have Bob Grenier's configuration, right? So if we go back to Bob Grenier's configuration, he went, okay, that's not what I wanted to do. Bear with me, chat. Bear with me. We're getting there. So he went north, south, south, north. So now imagine what the magnets are trying to do here, right? The field lines, this is curved field lines. Is there not a free draw? The field lines here are now trying to connect right here and here. And they're connecting right here and here. So you don't have a strong field out here or out here or out here or out here. You don't have that, right? It's just these inside field lines that are connecting. This one here is not going to connect all the way over. Or actually, it doesn't matter because these are touching, right? So you just have this inside that's connecting to these outsides. Now, if we reverse it, reverse the configuration. Now what do you have happen? Right? Now in this configuration, what are the field lines going to look like? These two are going to be touching. It's going to be very small, but they're touching each other anyway, right? So instead what you have happen is you have this happen. Right? This is why you're seeing the huge field lines in the second configuration versus the first one. Pretty crazy, right? So how can we manipulate this? How can we manipulate this? Huh. I gotta think about this more. Pretty damn cool, chat. That's what she said. Bob's Birdies. Any other good ones? Let's look at this one real quick.
In this first array, a k equals 1 array, the magnetization direction rotates around once as you go around the circle.
Oh yeah, now we're
Depictions
talking.
of it often show no field, but that's clearly not the case. You can see these little iron filings standing straight up as we set the bowl of them down inside the ring of magnets. This array kind of mimics a radially magnetized ring magnet, where the north pole is on the outside of the ring and the south pole is on the inside. Instead of no field in the middle, it's actually a complex three-dimensional field shape.
Yeah, that field's interesting.
Okay, here's the second Halbach array, a K=2 array. This is the interesting one we've looked at in more detail.
This is the array. So this array is the one that we were just looking at, the K=2. This is the same one we were looking at before.
Magnetic field across the middle of the gap. The field direction is pointing in an up and down direction. You can see the iron filings stick together in vertical lines here that show that. Rotate the magnets, and those lines rotate.
Oh wow, yeah, the lines rotate.
Okay, here's a K=3 array. This is a quadrupole. This
look at this one.
produces some really interesting shapes.
Anyone else thinking cymatics right now?
Poles kind of sticking out from the center.
Whoa.
I guess these things are used in particle accelerators because the strength of the magnetic field is weakest in the middle and it gets stronger the further you go out.
Wow.
And that's important for something.
Yeah, weaker in the middle, chat. You want zero magnetic
K=4 array
field.
is
You want to
similar,
have...
where the field strength is weakest in the middle and strongest at the edges, but it has 6 poles instead of 4. I guess that's a septipole.
What's this one gonna look like? Okay.
It's a little hard to see, so we poked around in the filings for a little bit. And you
Magnetrons?
Kind of like
that?
a snowflake. Definitely does make 6 points sticking out.
Oh yeah, look at that. Damn, this is cool. This is like cymatics. Yeah, we might be posting about Halbach arrays tomorrow.
There's that snowflake image.
Excuse me. Rotating motor.
Now to solve this, many different things. One of the most simplistic.
Yeah, okay, so here's the same deal, right?
Assembly like this would be used for.
So it's weak here because this is weak, and then this is really strong because it's bending. This is the north. This doesn't seem right.
Refrigerator. I cycle that, and around is a basic Halbach array configuration. What I'm going to do is I'm going to mount this on a rotor. The north facing one way, the south the other. Give it a spin, and just demonstrate that this alone is not enough to be able to build a rotating motor. Nor will this be. Here I've got some weaker magnets, and I've glued them together so that the
yeah, it's basically how
poles
toroid
are
for
facing
fusion
out.
containment works. Yeah, very
I'm
similar.
going to mount that.
Yeah, weak magnetic field in the middle, strong on
Show
the
that
edges.
This also, in itself, is not enough to build a.
I don't know what a
magnetic
magnetron is,
motor
chat.
from this
Now I'm
type
too
of
embarrassed to ask.
configuration. I think what it's going to come down to is trying to employ this type of configuration with another design, like assemblies that are pieced together with these type of configurations capping off the
I'm
assembly.
gonna change the name of the chat, the stream, because it's not really what I said it would be. It's magnets and Halbach arrays, let's call it. Oh, look at that. Yeah, see, chat, this is what I was talking about. Can we get it to spin forever?
Hey, this is my initial test of the rotor assembly.
Oh,
The
now we're
Halbach,
talking.
Array design here. This particular configuration is definitely not what I'm going to use later. It basically just bounces around in here. But I thought it might be worth a try.
Yeah, what if you run a current through them? Feels like, yeah, if we add a current to this.
Configuration is also going to be a no.
Definitely feels like if you set it up where you've got the strong magnetic field on the inside and the weak one on the outside, or maybe vice versa, I'm not sure, but that's what you would want to do here to get this to work.
Interestingly, if you use these smaller magnets, which have about 70 pounds of pull pressure, it doesn't matter whether you orient it as a north or as a south. It stabilizes in the field.
We're getting closer to over unity here, chat. If we had an electrical current, yeah, okay, now see, this is what I'm talking about. Now we're getting there. Yes. 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 It's closer. Needs more magnets. If you have the magnets going all the way around, that's probably what you need to do here. Halbach array on the outside. Inside have these magnets like this.
Dual configuration there.
I mean, there's not even, this guy doesn't even have a current on this.
Now, this is the beginning of my attempt to incorporate the Halbach array into one of my own assemblies, using it to cap it off, and I'll continue this all the way around. Interesting thing to note, if you've watched any of my previous videos, one of the things that I pointed out is,
okay, that's cool.
Unless you can start.
What's a magnetron? High vacuum tube containing a cathode and anode. Constant magnetic field modifies the space charge distribution and the current voltage. Huh. Seems too heavy. You don't want your thing to be too heavy. Okay. Yeah, who doesn't have a magnetron? Who doesn't have you anything? Anyone who's been watching for a while? How about, does this remind you of a coherent matter wave beam? This is the same configuration of the coherent matter wave beam, chat. This is why they made the cavities in it. Take a look at this. Coupled resonance cavities. Look at that. There's the cathode, there's the anode. It's literally the exact same thing. It's just much smaller. Guys, everybody in this chat is already like much smarter than the average person just from learning this stuff. It's pretty wild. Resonant cavity is a dielectric resonator. It's really, really good. It's pretty mind-blowing. Magnetic Rankle engine. Is there a video for it? I don't want to look up at papers. I don't think I have the energy. Rankle magnetic motor. There we go. How long is that? 1 minute. Perfect. There we go. Yeah, okay. Now we're talking. I'm guessing this banging is just to show that it's perpetual, huh? pretty cool. Oh, stream just got wiped out. Got orbed. We got copyrighted? Come on, man. I can't even watch a video for like 2 minutes. Yeah, even if it's educational, it doesn't even matter. They still get me. Exempt channels from content ID claims. I might just end it. I don't know. Details, technology. It's pretty whack. Okay, we should be back. Yeah, that was weak, dude. Tell them reaction videos show all the time. Yeah, I don't get, how do people get away with this with their reaction videos? And I can't even watch something for like 2 minutes without it copyright striking me. I just don't understand. Dude, it's like 2 minutes long. The thing's freaking copyright striking me. Just, it's like educational too. It's not even like freaking, nobody's making any movies off this crap. Well, I guess we can't even watch a 1 minute long video. What if I watch a 6 second long one? Is it gonna copyright strike me here too, YouTube? Jesus. It's like, give me a break on this. No freedom. Give me freedom. Twin rotor magnetic prototype. Like, do I just have to pause? They expect noise. Maybe if I just like mute it, then and I just keep talking over it, that it'll let me go. Okay, guys, we're reacting to the videos here. OMGs, can you believe this? These engines doing this stuff? Man, wow, this is so much dramas. So much dramas, chat. We're gonna react to this. God, I don't even know how it works. This was 1 year ago. Okay, so we put a bunch of magnets together. We do some stuff. We make a flywheel. Add the magnets to the flywheel. Boom, let it go. Bingo, wow. Reactions, epics. Very epics, chat. God. I can't believe I thought this was America. I thought this was America, chat. I thought this was America. Wow, very, very shiny, very neat. So much engineer. I feel like they just made 2 of these just to make it look cool. I don't know if there's any like practical purpose to make it do this. But, oh, okay. What if it just got faster and faster and then it just started like on smoking and then just they flew off? That'd be actually pretty cool if it did that. Good React content. That's how we do it, guys. That's how we do it. Jeez. Epic. Okay, guys. I think that's going to be it. Yeah, I think we've been going for long enough tonight. I'm going to try to get some other stuff uploaded. But yeah, this was a good science stream. Tomorrow I'm going to post this as well. This is somebody patented the graphite superconductor, room temperature superconductor. Graphitic room temperature superconductor. Look at that. We're going to begin to understand cavities. Not talking about your teeth anymore either. So, pretty cool, chat. Yeah, William, I was going to show some of your videos too, actually. Maybe I'll take a look at those real quick. So, William, is this you? Is this you here? Maybe I won't get copyright strike for this one.
See?
Guys, if this is William and I'm doxing him, it's not my fault.
And there's no cord in there holding it, okay? So
that's no cord.
Like that. Also spin it like this. My cross, another south pole.
So he made a cross here.
Push it into the middle.
It's going to be pushing back.
Hard to push.
Yeah.
But it feels like I'm pushing out on the field. Now the weird part is, and I'll come up here and get a little close. The weird part is when I get close to this copper.
Look at that dog. Dog, chat, dog.
Suddenly, it weakly attracts. See how it
That's weird.
wants to stick?
Yeah,
but
because
these are all just tube magnets.
So the reason here is that the same way when they built that ultra magnet or whatever it was, on one side of it's weak, right? In the very middle, there's a very weak magnetic force, but the magnetic field lines would be connecting from here down to here and from here to here, right?
All have the same.
These two are going to be connecting like this, and then it's also going to be connecting to the one here. It's going to create a pretty complex pattern.
South pole pointing this way. So there's no reason that when I get to the center of this ball of magnetism in there, that it should attract like that. It should repel it no matter what.
These are some nice Carhartt gloves you got going on. Those engineering gloves.
So
I would think it would repel it though. Pretty cool though. Tiny Dog is her name. That's cool. Okay, so yeah, show us more videos tomorrow. I'm gonna untag that one, untag this one. We looked at those. This was a disappointment. Although this is interesting that there is infrared that is reverse thermal. Black is hot in this video. So we know there's infrared that has black as hot. Why is that important? Because when we look at the MH370 satellite video, we see a cold event that's white, which would indicate that the satellite footage is inverted heat, which is interesting to think about. Because we also don't know the sensitivity. Close that out. Close that out. Anything else? I'm going to click this and see what this is all about as well real quick. 31 minutes.
This scientist believes that man holds the secret of anti-gravity and can produce flying...
Too late to know who had opened Dr. Tesla's safe or what had been removed.
Yeah, we're going to probably get
Dr.
copyright
Trump
strike
had found
here
nothing
again.
which he considered dangerous or a secret weapon.
We'll see if we can last for 30
Since I've
seconds
been a
here.
naturalized American citizen for 54 years.
YouTube's probably going to catch us, I
So
feel
why
like.
were his papers seized by agents of the custodian of alien property? I suspect that governments other than those of the United States, England, and Russia.
Yeah, it's not technical. That's happened before to me. I have to like pause it every so
Were
often.
interested in the inventions of
Talk
Dr.
through it.
Tesla.
It's not technically a copyright strike, but it's a warning when they catch you.
1943, the year of Tesla's death, was destined to become a year of the most imaginative scientific experiments in the history of the world.
Project Rainbow says resonate toroidal magnets. I'm guessing he's talking about not 31 minutes in, he's talking about 32 minutes in.
Massive toroidal electromagnets around the hull of a ship to make it disappear.
What?
The only thorough investigation of this highly classified
Sorry,
and bizarre
what?
experiment
What did he just
has
say?
been carried out by Charles Berlitz and William Moore. Massive toroidal under the impact of guided missile bombardment
You
from
guys just hear what I just
German
heard?
Europe. America was involved in one of the most amazing and fantastic experiments ever devised by man. Codenamed Project Rainbow, the objective was to place two massive toroidal electromagnets around the hull of a ship to make it disappear. The only thorough investigation of this highly classified and bizarre experiment has been carried out by Charles Berlitz and...
Well, I know what I'm looking up tomorrow. Project Rainbow? What is the hell is that? Charles Berlitz.
William Moore, co-authors of The Philadelphia
hell?
Experiment.
They had two enormous degaussers that established a field of resonance, which initially, as I said, was to make clouds of ionization around a ship and make it invisible, as well as invisible to radar. But what happened was much more surprising and unsettling than that. The ship seemed to glow in the field, and all of a sudden, with a sort of the way you put on a...
Be careful when you type Project Rainbow. Damn, this is crazy, chat. Holy crap. Could the Philadelphia experiment been real? The Philadelphia experiment always bothered me. Well before I thought... I didn't used to think that teleportation could be possible, so I just thought the Philadelphia experiment was some weird thing, right? Where I couldn't figure it out, but it seemed like it was a real event that happened, right? Like, battle cruisers don't just disappear, right? There's no explanation. So, but man, they pretty much just explained what happened in the videos. They pretty much just explained what happened in the videos.
A neon light, except in reverse. It flicked off instead of flicking on, and there was no ship there. I believe the experiment was done once more at sea, and it was the fact that the experiment was done at sea under better conditions that it became more or less public knowledge, because the disappearing
because a boat just disappeared?
Destroyer was seen by a ship in convoy to disappear at only at 100 yards away.
100 yards away. That's pretty damn close, chat. Whoa, this is wild, guys. Okay, we might have to... Damn, toroidal magnets were involved in the Philadelphia experiment? Project Rainbow? I don't even know what Project Rainbow is.
A group of scientists had been working towards these experiments for some time. They were headed by Dr. Albert Einstein and included an American electrical physicist.
Thomas Townsend Brown. Holy shit. Oh my God, I recognized him. That was Thomas Townsend Brown.
And is still alive.
Chat, this rabbit hole is getting scary, chat. This rabbit hole is getting scary. Thomas Townsend Brown was involved in this?
By the way, is perhaps a very typical example.
Guys, how the... Okay, we're going to save this for tomorrow, chat. We've got a pretty spicy thing to look into tomorrow. Everybody who's in the Discord, feel free to start digging up this stuff. I might make a new channel for it because we're getting a lot of our stuff mixed together. Also, I want to try to avoid in the Discord some of the spam and some of the channels. It's getting too hard to track some of the content because there's just too many posts that are going in some of these channels. So if we can keep the cross chat out of like the evidence channel and stuff like that specifically, that would be really great. There's a lot of cross chat in the evidence channels, and it makes it really, really hard to find stuff that's up there. So I'm gonna go ahead and send an invite out. We'll do, we'll allow 10 uses of this one for one day here for people that want to get into it. I'm not gonna do any more tonight, guys. I'm done for tonight, but I will take a look at it and we'll look into it more tomorrow. Yeah, so we will check out more of this stuff tomorrow. We'll check out the Project Rainbow and probably as well the Philadelphia experiment. I want to see if we can find any information on this. Pretty interesting in general. But thank you guys for joining us tonight. We will be back tomorrow digging more into some of this stuff. I might, if I find a space, I may join a space later tonight, but probably good on it for tonight.